All right, so if you turned the page and you did the examples at the top of the page from the last video, these are the answers you should have gotten. Make sure as you look at these are coefficients. So we want to go ahead and divide coefficients as we would. We don't treat these like exponents. You're not subtracting here. These are not exponents, so don't apply the rule to them. These are coefficients. It's telling us to divide. 14 divided by 2 is 7. We apply the rules to the exponents here. Make sure z has got a -6 with it. We got to move it up to the numerator for it to become a positive exponent. Again, never leave a negative exponent in your answer. Now with letter E, this is the first time where we take the exponent and when we divide it by the index, we get a remainder. So here 8 divided by 4 is 2, so all the A's come out. But with B, we have 5 divided by 4, and that doesn't divide evenly. 4 does go into 5 one time. So if you had written this out as to 5 B's, 4 of them would get circled and a group of 4 would come out. But there would be one left that wasn't circled, and that would stay underneath the radical. So what we do is we say 5 divided by 4, well, it goes in there one time, so b to the first comes out, and there's a remainder of 1, so b to the first stays under. Okay, here's another example of that same type of problem. 4 is going to break down into 2 2's. Well, that's not enough to come out, so we're just going to leave that underneath the radical. When I divide the exponent 8 divided by 5, that doesn't go in evenly, but 5 does go into 8 one time, so a to the first comes out, and there's 3 left over, so those 3 that are left over have to stay underneath the radical. When I take 14 and divide it by 5, 5 goes into 14 twice. That's why b squared is out here. But there's 4 left over. 5 times 2 is 10. There'd be 4 left over, so they have to stay underneath the radical. And then 5 divided by 5 is 1, so c to the first comes out. So the things that come out get listed first. So a, b squared, c get listed first. And then we just put the radical at the end. And it's still the 5th root, because that was the index. 4, a to the 3rd, b to the 4th. All that did not get circled or has to stay underneath the radical. Okay, let's go back up here to f. When you divide here, we can do some simplifying here. X to the 4th divided by x to the 1st. I simplified that and got x to the 3rd, y to the 2nd over 125. That makes it a little simpler for me. Then when I take the cubed root of the numerator and the cubed root of the denominator, well, the cubed root of the denominator comes out to 5. When I take the the exponent and divide it by the index, 3 divided by 3 is 1, so x to the 1st comes out. There are no leftovers. But x to the 2nd, there's not enough, y to the 2nd, there's not enough to come out, so they're going to stay underneath there. And then here again, we've got coefficients. 6 divided by 3 is 2. And when you subtract your powers, this is what you'll get. This is written in rational exponent form, so my answer I'm leaving in rational exponent form. This was given to me in radical form, so I'm leaving my answer in radical form. So you kind of get the hang of that. Okay, the last thing we're going to look at this week is we talked about like radicals, radical expressions with the same index and radicand, and you can only add or subtract like radicals. They have to be like each other in order to add them. Kind of like terms with x's and y's and z's. You have to have like terms in order to add or subtract. So example A here, we have a 4th root of 10 plus 7 4th roots of 10. This is a 1 in front. That's a coefficient of 1 when you don't see anything there. And so since they're the same radicand, they're both 10s, and the same index, they're both 4th roots, these are like radicals. So we just take their coefficients and combine them. 1 plus 7, this would be 8 4th roots of 10. Okay, here, this is written with a rational exponent. I'm actually going to change that so you can see what this looks like with the radical. This would be the 5th root of 8 to the 1st power, and there would be 10 of these. This would also be the 5th root of 8 to the 1st power. So this is actually, the radicands are the same and the indexes are the same. So these are like terms. So again, we're just going to combine our coefficients. This is going to be 12 5th roots of 8. And sometimes it's very helpful to take it out of rational exponent form and see what it looks like as a radical, or vice versa. Sometimes it's helpful to take it out of the radical form and put it in rational exponent form. So hopefully you're able to by now do that. Now when they don't have the same radicand, we cannot subtract these like they are. But don't give up on the problem yet. This 54, this needs to be simplified. There are factors of 54 here. 9 times 6 is 54, 9 is 3 times 3, and 6 is 3 times 2. So it's because it's a cubed root, I'm looking for 3 of the same factor. So a 3 is going to come out, and then the 2 has to stay underneath. And now when you look at the problem, okay, this does not simplify. But now we do have like radicals, and again, you don't see a coefficient here, that's a 1. So we'd take 3 minus 1 and say that's 2 cubed roots of 2. Here we're back to multiplying, and I kind of just threw that in there. Remember that this like radicals only applies to addition and subtraction. So with multiplication, if you go backwards in your packet and go back and look at that, we can always multiply the radicands together. So this would be the 4th root of 27 times 3. Well, 27 is 9 times 3. 9 is 3 times 3 times 3, and then this 3. So there's going to be, we're looking for the 4th root, so there's going to be 4 3's in here. That's just going to equal 3. And then here's some division. Again, like radicals does not apply to division. It only applies to addition and subtraction. So I could go ahead and divide this. Because 250 is divisible by 2, I'm going to combine that into one fraction underneath my radical, and I'm going to divide it. 250 divided by 2 is 125, and then I'm going to break that down and see what I have here. 25 is 5 times 5, so that is 3 5s, so that's going to equal 5. Now we've got some subtraction and addition going on here. Again, we're looking for like, because it's addition and subtraction, we have to have like radicals. So none of them are like each other right now, but I'm not going to give up on it yet. I'm going to simplify some things. 20 is 4 times 5. This would be 2 times 2 times 5. Well, since this is a square root, I only need 2. So there's my 2 2's, and the 5 has to stay underneath. So I'm going to simplify the square root of 20 into 2 square roots of 5. With 16, that's 4 times 4. This would be 2 times 2 times 2 times 2. This is a third root. Okay, this is a third root, so I need 3 of the same. So I've got 3 2's, so that's going to be a 2 is going to come out, and then the cubed root of 2 is going to stay. Okay, these are still not like each other. This is a square root and this is a cubed root, so we would not be able to subtract those. But let me see what's up here. This is a 2 times 125, and we just did the cubed root of 125 over here. That came out to be a 5. So this 125 is going to be 5 times 5 times 5. So there's 3 of them. So this is going to be a 5 cubed root of 2. Uh-oh, look at that. We've got like radicals now. And then over here we've got minus the square root of 5. And 5 does not break down into smaller factors. So now that I've gone through and I've simplified everything, I've got a square root of 5 and I've got a square root of 5. Those are like each other. And again, you don't see a number in front of here, so there's a 1. So this is 2 minus 1. That would be 1 square root of 5 if I combine those. And then these are like each other. They're cubed roots of 2. So this is a negative 2 plus 5. That's a positive 3 cubed roots of 2. And this is where, let me move that up so that you can see that. Oops. There would be my answer. This first and this last term were like each other. They're both square roots of 5. 2 minus 1 is 1 square root of 5. You don't have to put the 1 out here. And then these are both cubed roots of 2. So negative 2 plus 5 is a positive 3 cubed roots of 2. And that's where I leave my answer. Okay, I've got a worksheet attached for you to give some addition and subtraction, some practice there. Okay, join the Zooms. This is a lot of tough stuff, lot to digest and think about here. So please be attending the Zooms every week and email me your questions.